Welcome back. Hope everyone had a good lunch. I am Curtis Rueden. I'm the lead software developer at LOCI here in Madison, and I'm going to be talking about the ImageJ 2 project and the Fiji distribution of ImageJ, which are very related but separate, distinct things. So, just for fun, quick poll of hands. Who knows the difference between ImageJ 2 and Fiji? 1, 2, 3, 4, 5, 6 people. That's what I thought. Kevin and I joked that we should make a shirt that says ImageJ 2 in Fiji, and then on the back it just says blah, 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 because every time I try to explain it, people, it's a lot. There's a lot of buzzwords and, all right. So, I want to start off with a little anecdote. A colleague of mine once told me that it's not the code that matters, it's the community. If you were paying attention to Kevin's presentation at the beginning of the day, he said something very similar, actually. And I think there's some wisdom to that, but I would also counter that you can't build a house with your bare hands. So, well, maybe you can, actually. Some people have done this, but there are limits to what you can build. I would actually say you can't build a house alone either, so you need the community, you need a team, and you need the tools. They're both necessary. And then you can do great things. But before we get too heavy on analogies, let's think about this. Creating software isn't like building a house. People like to talk about cars a lot and houses a lot when they talk about software. And I think there's a lot of problems with that. It's actually more like designing a house, like an architect, right? So once it's designed, you can mass produce the software. You can copy it on a USB stick. You can give it to anybody. The design keeps changing and changing. It's not like you finish your software and then it's done forever. So I don't think this analogy is necessarily even worth keep doing. So I promise no more analogies. I'm just going to talk about ImageJ as is, and I won't compare it to a car. So first, I want to cover a brief history. Wayne touched on this in his talk as well. In very broad strokes, ImageJ started in 1997, and before that he was doing NIH Image in 1987, passing it around on floppy disks. If you want to hear the thorough history of this, there's actually a great paper called 25 Years of ImageJ that you can check out. It's not a technical paper, it just talks about how the story of Wayne Rasband and how ImageJ came about and how it got to where it is today. In 2007, Fiji project started. Fiji was not the first project to try and do what it was doing, but it was the most thorough, successful, effective one, I think. Before that, there was one other project called WCIF ImageJ or MBF ImageJ, which was quite popular for microscopy. And it was, what it is or was a collection of plugins. So the thing about ImageJ is everybody is writing plugins for it all the time. And so eventually you get a hodgepodge of plugins that you're trying to keep track of on your computer. And so someone for microscopy, Tony Collins, he put together this, what he called a distribution of ImageJ with all the plugins. And so that was what people used in the mid-2000s. But then when Fiji came out, it really changed the game. So it was a large collection of plugins, all bundled together. And that was started by two guys, Johannes Schindelin and Albert Cardona. And the reason Fiji was started wasn't for everyone right away. It wasn't to be a collection of tons of plugins. It was started because this guy, Albert Cardona, had a really complicated plugin called TrackEM2 for doing registration. And it was so complicated that it was hard to even send it to anyone and have, like, they had trouble setting it up in their ImageJ. It had so many prerequisites and requirements. And so he got together with Johannes and they created a pre-downloadable bundle thing that came with TrackEM. So TrackEM was the first flagship use case for Fiji. But since then, many, many more plugins have been added. So what Fiji was then is not the same thing as what it is today, and I will cover that in future slides, but just so that you know, that's where it started. It became a distribution for life sciences later. In 2009 is when we started the ImageJ 2 project, and we were a little reluctant to call it, we didn't know what to call it because it was an attempt to create the next generation of ImageJ, so it was a bit orthogonal to Fiji. So Fiji is a distribution of plugins, whereas ImageJ 2 is an attempt to re-architect and redesign ImageJ to be more general, more powerful, to have all the good things that ImageJ does, but also be able to do more. And so for the next century worth of scientific image data, because there over time became clear there are some things that ImageJ was very good at and some things that it couldn't do well. And so this project got funded on an economic stimulus grant, actually, so Obama bucks, basically, right? It was only 2 years from the NIH, and we hired a bunch of people, and we had 2 years to really work hard on it. So it made an initial burst of progress. And since then, now it's 5 years later, and since then, we've had to keep adapting to be able to keep working on the project, but I'll talk about that in a bit. So then, finally, in 2011, the last major milestone is that we started a broader consortium or initiative called the LOCI Java project, and it's a generalization of some of the things we were doing in ImageJ2. So we realized in ImageJ2 that a lot of the things that we needed and that we wanted had nothing to do with images. It was just, we need to write this code to be better with script languages. We need to write this code to be better with plugins and make plugins more powerful. And all those things had nothing to do with images, and so we generalized those furthermore into this LOCI Java project. And that was the technical side. And the social side of LOCI Java is that it was an agreement between a lot of different groups who had a lot of different projects, including ImageJ, OME, NIME, Cell Profiler. All these groups agreed that we were going to work together more and try and share code more. And so you'll notice that that's the trend here, right? Small number of people moving down into more and more people until the very end, we've got a boatload of people. So I'll show you my boatload of people slide in a little bit. Just really quickly, for those of you who are already familiar with ImageJ2 a little bit, and Fiji, and just wondering kind of what's new or what we've been doing, this is the timeline of major milestones that we've done in the last 5 years since ImageJ2 started. So the Fiji project was and is very ambitious. They wanted, in order to ship all these plugins to people, this collection of plugins, they added this updater, right? So I'm just going to ask so I don't belabor the point. How many people here use Fiji? Okay, so everybody's used the updater. You've been nagged by it. You got an update every 5 minutes. It's annoying, right? But on the other hand, it's nice because it means you don't have to go and download it every time. And you can choose to ignore it if you want to. So in 2011, what was added to Fiji was the idea of update sites. So instead of it's just you're getting an update from Fiji, it's you subscribe to different websites that have plugins in the checkboxes, right? In that manage update sites dialog. And then you can pick and choose which ones you want. So that was when that was first added. In 2012, that was when we first released the beta of ImageJ2, and we've been iterating ever since. In 2013, Johannes Schindelin did an amazing thing, which is that he created what we call personal update sites. So we allocated a bunch of space on our server so that people could make their own update sites without needing their own server. Because what we found in 2011 very quickly was, yes, you can make your own update site, but do you have a web server? Are you paying for a web server? Does your university give it to you? These kinds of things, a lot of people just didn't have the capability, the technical chops or whatever to do that. And so personal update sites are intended to make that super easy. And I think that was a big boon because now we have 100 personal update sites, and almost every really big flagship plugin is served by one of those. So that's pretty awesome. In 2014, Fiji really became ImageJ2. So I'll talk more about that when I get to the technical slides. But just know that Fiji was built fundamentally on ImageJ 1.x, classic ImageJ, while we were busy trying to make the next version of ImageJ. And in 2014, things were far enough along that we took Fiji, we picked it up, and we stapled it on top of ImageJ2, and everything kept working, mostly. And we ironed out the problems. So that was a huge boon forward. Along with that, later in the year, we brought this ImageLib2 library out of beta, so that's one of the major imaging components of ImageJ2, and the Fiji builds became more robust. So essentially, there's just been a lot of effort to try and make the code all very strong, very stable, very mature, robust. And then in 2015, it's more, I couldn't even find the best thing to put on this slide because when a lot of these are links. So if you can follow this presentation yourself if you want. I can find my mouse pointer. Here we go. So this presentation is at imagej.github.io/presentations. So for anyone who's really bored and wants to just click around, you can. It's this one right here. So this whole presentation is online already. And a lot of these are links that go to whatever blog post or something. So if you want more details, you can find it. So here is my write-up of what's new in 2014 and what we're going to do in 2015. And It's all very coherent and it's all very focused, but there are several different goals. So I didn't try and choose one here. There's just, we have a lot more, we're doing a lot of hackathons and a lot of social coding, so more and more progress. We also always post what's going on in ImageJ on this news archive here, so whenever a major thing happens, we post it on the news. I also try and tweet it when it's really big and put it on Google+, if you like that kind of stuff. Right. So this is a slide with a bunch of bullet points, and everyone who makes a presentation tells you not to make this slide. And it's really hard to absorb. And that's why I put it in different colors. It still doesn't make it easy to absorb. At least it makes it pretty. So I'm going to boil this down a little bit. I made up the mission of ImageJ2 when I first made the website in 2010. And these were what I came up with as sort of the foundation of what we're trying to accomplish with this project. So I'm going to boil it down for you, and then I'm going to walk you through each of these points from a few different perspectives. So creating the next ImageJ is basically software design. That's more of a technical thing, but it also has a social aspect to it. Collaborating with other people is a huge thing we're trying to do with ImageJ2, as you probably gathered already from the side Java effort. Making ImageJ broader for a broad community, that was a major goal, because one thing we found with Fiji was that since it started in the microscopy community, that microscopists liked it, and life scientists in general started to get interested in it, but there are people in other disciplines of science who thought, oh, Fiji's not for me because I'm not a microscopist. But actually, there were so many things that really had nothing to do with microscopy in Fiji. So we're trying to broaden the target audience and also broaden what ImageJ's capabilities are. So this is a technical goal as well, like make it n-dimensional instead of 5-dimensional, for example. We want to, while doing all of this, maintain backwards compatibility, which if you're a technical person, then you know how hard this is. It's extremely challenging, and we have put in hundreds or thousands of person hours into this. I'll explain how it works later. We also wanted to kind of unify the ImageJ resources that are out there. So Wayne does a great job of trying to track everything happening and putting it on the main ImageJ website on NIH.gov. But it's so much, and it's huge lists of plugins, and it just is overwhelming to try and find things. And so we wanted to find a better way of creating one centralized resource. And lastly, we want to try and lead the development and lead the discussion a little bit, just so that, you know, everyone, if everybody is, if everyone's doing this in their spare time and no one's paid and we're all just trying to make it better, it becomes very difficult to move forward. And so it's helpful to have a vision, right? And the vision of ImageJ1, I asked Wayne once, I said, what is your vision for ImageJ1? And he said, I don't really have a vision, but when I talked to him a little bit more, and he does, actually. He has an excellent vision that's worked really well for 20 years. It's just a simple vision. It's, I listen to my users, and when they need something, I do it. And so because of that, it's become very powerful and very popular. And I'm sure there's also a lot of prescience there and forward thinking about what would be useful for people. But really, ImageJ has been driven by these iterations. And so we wanted to say, well, that has gotten us to where we are today, but how will we accomplish this broadening? Well, to do that, I think we're going to need to have a discussion about a bigger vision. Okay, so the meat of my talk here is going to go through these 6 points from different perspectives, and I'll introduce you to like what is ImageJ and a few things like that. It's important to understand, like I know there's a diverse audience here, and some of you are scientists, and some of you are developers, some of you maybe somewhere in the middle. And so I've divided things into kind of 3 levels of scariness. We've got the social stuff, which is about people. We've got the architecture, which is more of a top-level view, big picture idea discussion. And then we have technical slides, which go into more detail. And for those of you who are developers, this is probably still not enough technical detail for you. And that's just because it's only a 45-minute talk. So click the links, go to the GitHub sites, whatever. You already know how to do that stuff. So, all right, so first, let's talk about software design. When we started the project, it was an ambitious project, right, with big ideas, but we wanted to figure out what exactly do people need. You know, we're supposed to be doing this based on the needs of the community. Well, what are those needs? I mean, we had a pretty good idea because that's why we submitted the grant proposal. But still, I wanted to poll the community, and so this email mailing list started called ImageJX, where we kind of had a discussion among a lot of people about the sorts of things ImageJ would need to do in the future. And we got some good ideas there. This picture is actually from the 2010 ImageJ conference. They did some polls, and I found this one very interesting because as you can see, there's a clear winner here, that its plugin structure gives me flexibility. So people really love the extensibility of ImageJ. That is the number one thing I think that is super awesome about it. There is another great thing, which is that it has a lot of stuff in it. It has a lot of available functions. Wayne has put tons of work into it, and people have added even more functions, right? So that just what it can do is an obvious choice, but I think the fact that it's so extensible is really powerful. As far as what is missing, or what could be better, or what do we need, a bunch of stuff, like you heard me mention already. We wanted to generalize it, make it n-dimensional, make it be able to support more kinds of data, make it more modular. So one thing about ImageJ 1.x is it has tried to stay very small and not have any dependencies. And so we wanted to be able to support building blocks on top of blocks so that you could have more powerful features. We wanted more interoperability, which means ImageJ working well with other tools. You've already seen some workshops on that, like the Omero workshop and building bridges between ImageJ and Omero, and there's going to be more later. And then more extensibility. So if this plugins are so great, why not make them even better? Because there were some efforts in Fiji that had already begun along those lines, and we just took it and ran. So I'll tell you about that. So this is the $1 million question that everyone always asks me. They ask me two questions. What is ImageJ2? And what's the difference between that and Fiji? And so I'm going to go through some stuff, and it's blah, 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 and hopefully it'll all make sense. But yeah, so from a perspective of users, it's an application just like ImageJ1. In fact, it in very many ways is ImageJ1, ImageJ still, but it has a bunch of extra stuff, more things. From the perspective of a programmer, it's a reusable library. Of course, ImageJ1 is also a reusable library, but it has certain things you can't do with it because it was fundamentally designed with certain requirements, and so we're trying to broaden those requirements. From the perspective of someone who really wants to build complex tools, like say the micromanager team or anyone who's building something really complex on top of ImageJ, it's an extensible collection of things. So we made the plugin model really, really powerful so that you can build everything as plugins on top of SciJava on top of ImageJ. And then what I think is the most exciting part about ImageJ2 now is this project called ImageJ Ops, which is, I like to call it write once, run anywhere image processing routines, and that probably doesn't mean anything to you unless you're a Java programmer. But the idea is that you should write your algorithm once, and then it should just work in a lot of tools. It should work with a lot of different kinds of images. You shouldn't have to keep rewriting it and porting it in between all these things. And so that was Java's idea, was to have you write the code once, create the distribution of binaries, and then you could copy them to any computer, whether it's Mac or Windows or whatever, and have that work. And so Ops strives to do the same with algorithms. Right now, I think if you have to write your algorithm once, you write it in a paper, right? And then you say, it's up to everyone else to implement it. But the hope here is that we can do better than that and actually have the code be written and it works everywhere. So the last thing ImageJ2 is, as I said, is just an effort to generalize and kind of overcome a lot of the limitations of ImageJ1. So this is the plugin framework. This is 5D, this is multidimensionality. This is the fact that right now there's a 2 gigapixel limit per plane, and so we've overcome that with the ImageLib library. Different pixel types besides just, you've probably seen the image type window menu with like the few different options there, and so ImageJ2 supports many more of those. And being able to access data from other locations besides just files. ImageJ1 can, to an extent, do URLs, and to an extent, you can code in other things, but fundamentally, it kind of assumes that you're working from files and that it's already opened all the data in advance. So more and more now, you guys know cloud computing is becoming super big. You can rent space on the cloud of Amazon S3 or whatever and have just massive data sets. And so you should be able to read these on demand, only the pixels you care about, do your processing and have it be persisted, and not have to worry about waiting for 17 hours for your data just to load into the program. And then in general, ImageJ is very focused on the paradigm of like classical desktop computing, which is that you're only user of your machine, you have one desktop, you have one machine, and more people want to do things like cluster processing and so on. So ImageJ2 is an effort to move things in that direction. All right, so now we're getting to the scary red slides. So this is not that scary, actually, because I wanted to keep it short. What are the components of ImageJ2? Well, really, there's two things that you need to worry about. There's ImageJ itself, and there's SciJava, which is the things that are more general than images. So all of the ImageJ things are image-specific, and all the SciJava things are more general, like how do plugins work, and so on. If you want more details, you can go to the websites. Let's see. Oh yes, and if you are a developer who wants nitty-gritty, super details, you can go to that architecture page. I've worked very hard for many hours on that page, as you should all admire it. Okay, so the second part of our mission is to collaborate with people. And that's why we started SciJava. We wanted to make things talk to each other more. And so this slide is just sort of a thank you to all the people who are currently involved in this effort in a very active way. These are people who are writing code on a regular basis, contributing to this project. And there are some new people who are getting into the fold as well who aren't up here yet, but this is just sort of the people who are tried and true. I want to give them hugs, those kinds, And then the top row is all the PIs who have been very supportive and have found money to send people to different hackathons and conferences. And to everyone who supports open software, thank you as well. So from a high-level perspective view of architecture, we have this SciJava pledge that we all agreed to reuse stuff. What does that mean? What does it actually mean to reuse each other's stuff? Well, that's too broad, right? So you have to get down to details. But first, I just want to say these are the projects that have actually taken strides on a technical level to reuse each other's stuff. And there are other projects that we still discuss things and work together, but really in these projects, there's at least been some code sharing or some like attending a hackathon and hearing about each other's tools. So that's pretty fantastic. From a really technical level, what does it mean to reuse each other's stuff? Okay, well, there's a lot of different ways of doing it and aspects, but the number one thing I want to tell you guys about is parameterized modules. So they're called SciJava modules, and it's a more flexible, or it's a more robust way of defining your algorithm. So you say my algorithm needs to know, a sigma value, and it operates on an image, and it will produce another image. And when you do that, you declare it. Okay. So these are some parameters on the left. They're all strongly typed. And this is a screenshot of the Cell Profiler application showing the plugin that declares these inputs and outputs, and it's asking the user for them in its window. But when you run this in ImageJ, a different dialog box pops up that asks you for those things. If you run it headless, it'll presumably scrape those values from your script or from typing on the command line or whatever. So, and then as well, the KNIME tool supports this, and a couple other tools support this. So the point is that you write these parameters down, you write the Java code, or you can write in a lot of scripting languages too, actually. You heard a lot about that this morning, probably. And those are all expressible as modules, and so they're all usable in all these tools. So there'll be a workshop tomorrow that I'm doing with Brian Northen where we'll go over the details of how this parameter thing works. All right, so moving on to broadening, making ImageJ more useful to more people. So from a social perspective, we have to think about who the target audience is. It's scientific people, software developers. It's the same diversity that we have at this conference. And so, the question is, well, how do you please all those people? Well, my first answer is you have to give them things to try quickly and then respond to their feedback and then keep iterating and keep iterating. So you can't write a thing and have it be correct and it's just everyone's happy. It never works. There's always problems. There's always things you didn't think about. And so you might wonder, well, why isn't ImageJ 2 done after 5 years? Well, it's because there's always problems. You have to keep iterating. We're getting more and more mature and stable, and we'll get to the point where we can stop calling it beta, but it'll still be a little while longer. So another great way to deal with this, to the diversity of the audience, is what we call separation of concerns, which is probably the number one thing that ImageJ 2 is trying to do, is to separate concerns, to not have displaying images be mixed in with computing things on images, and to have everything be kind of nice and separate and encapsulated. So as part of that, when we partnered with Fiji, we started to migrate all the great stuff that Fiji had done, like the updater and non-life sciences specific things, into the core of ImageJ. So ImageJ now has a script editor, which came from Fiji. It has an updater, which came from Fiji. But these are no longer Fiji things. They're ImageJ 2 things. So I hope that makes sense. So in a nutshell, the difference between the Fiji and ImageJ 2 is that ImageJ 2 is the core that has all these goodies, and Fiji has built on top of it all these life sciences plugins, some of which are probably useful outside life sciences still, but it's a distribution. Fiji is a distribution. It's batteries included, download everything. And ImageJ 2 is a smaller core. We also want to migrate image processing algorithms into the ops library I mentioned, because that's really the most separate, encapsulated way of doing that. And this third point, broaden the image metadata. This is something I think is really cool. So one of the libraries that we've developed as part of ImageJ2 is called CIFIO. That's the middle guy here. This guy right here, that's CIFIO. CIFIO is for data input and output, and that's the thing that makes this possible to read images from things other than files. And it grew out of bioformats, because I developed bioformats starting in 2005 with Melissa Linkert. And over many years, we've learned a lot of lessons there, and bioformats has definitely matured a lot, obviously, and has gotten really powerful and many formats supported. But I knew that to support n-dimensional data, I'd need something a little bit more general. And also, bioformats has been very focused on microscopy metadata model, so the OME data model, which is fantastic if you're doing that kind of work. And if you want to work with images in, say, astronomy or earth sciences or material science, it's not applicable to you. And so we needed a thing that was more extensible, so that anybody from whatever scientific domain could essentially write a plugin that is their metadata model. And so that's where CIFIO comes in. It makes that fundamentally possible because plugins are so powerful. And then lastly, we want to migrate all the non-imaging things to SciJava. So for example, the scripting, all the multiple script languages, that stuff is all inside Java. It's not image specific. All right. So from a technical perspective, the n-dimensional data model of ImageJ2 is built on ImageLib2, and 1,000 thanks to the developers of ImageLib2. Seven Salfeld is here in the audience, and he's the mastermind, I think, behind the original architecture, him and Stefan Preibisch. And those guys did an amazing job creating something that's very well thought out and really has a good separation of concerns. So we built on top of that for ImageJ2. And then furthermore, on top of ImageLib2, we built this ops thing. So like I said, it's write once, run anywhere. That means you should be able to write your algorithm once. I had 3 goals when we designed ops. We started designing ops last year at the beginning of 2014. And our goals were to make it powerful in general. That was easy because ImageLib is powerful in general. To make it easy to use and extend, and we're still working on that part. It's always difficult to teach people technical things, but I think that it's quite easy to use from a basic standpoint, and it's just a matter of even knowing what's there and what kind of image algorithms are available. So we'll work on documentation there. And then lastly, performance. And so performance is always a problem. Whenever you generalize something and make it support more and more things and n-dimensional and all this stuff, you can often make mistakes and have things get slower, right? Or just the design requires things to be slower. And so we solved that in ops in a way that I'm really pleased with. And so I just want to quickly show you, for those of you who are programmers, you probably are familiar with the concept of like method overloading, right? So the idea that you can have a function called add, and it might add 2 numbers, but you might have another function also called add that adds 2 images together. You might have a third one that adds an image with a number, a constant. And so we created ops to let you define your own extensions to those functions, okay? So you can make up your own functions. You can make up a function called whiz if you want, but you can also write a new function also called add and have it add 2 things that are not part of ImageJ normally, that you've invented your own data objects, and now you can make them add together in the same way. And so this extensibility is really profound because you can also use it for performance. So you can do the write once thing where you write an algorithm that supports any image, and then you realize it's really slow on the comment like images I opened from a file on disk. And so then you can special case, you can write another add that adds just that kind of image, but does it faster. And so in this way, you get the advantages of case logic, but without going, if this, then do this, else do this other thing, else do this other, like that's not extensible. And so ops overcomes that in a plugin model. It's basically a giant case statement with plugins. All right, so moving on to maintaining backwards compatibility. So this was fundamentally, profoundly challenging because we wanted to design, we were ambitious. We wanted to design this n-dimensional data model. We wanted it to be a lot more powerful. And ImageJ1 you can actually see over the years how it's grown from 2D to 3D to 5D just by, if you're a programmer and you look at the API of it and just like how the classes are structured, you can tell that that's what happened. That it was not 5D originally, that it started 2D and then it went 3D and then Wayne added 5D on top. And that it's by necessity, right? You have to do that if you want to keep things working, like old code still working. But there's always, so right, the fundamental problem here is that ImageJ has this wealth of functionality, and it's still growing. More is being added every day in response to user requirements and ideas that Wayne has. And so how can we make sure that all of that stuff still stays in the hands of users while also pursuing this new stuff? It's a huge challenge. And so my first hackathon was in March of 2010, and I spent the whole hackathon just discussing with people how we might do it, and drawing pictures on whiteboards and trying stuff and then throwing it away because it didn't work. I think I tried 4 or 5 different approaches that all didn't work. And so I just want you guys to know that it took a really long time and it was really hard. And what we ended up with was the product of that. And so if you have ideas on making it better, that's fantastic. But a lot of thought has gone into this. So the takeaway here when it comes to this ImageJ, classical ImageJ 1.x versus ImageJ 2 is what's the difference? ImageJ 2 is ImageJ 1.x now. It comes with ImageJ 1.x. When you download ImageJ 2, you are downloading ImageJ 1. And it's the latest version always. It wasn't this morning, and then Wayne pointed that out to me, so I updated it. But it's supposed to happen automatically. So ImageJ 2 includes ImageJ version 1. And the way that this works is that ImageJ 2 stands alone as well. So it's a complete redesign. You can run ImageJ 2 without ImageJ 1. That was very important. And what user interface you get is a plugin as well. Everything's plugins. And so you can make it look however you want. So to make ImageJ 1 work, we just made a plugin called the Legacy UI that uses ImageJ 1 for the user interface. And so if you're using that user interface, then you can mix and match. You can choose what you want to do in either tool and mix them. And that will be shown in the workshop tomorrow if you're interested in starting to leverage the parts of ImageJ 2 that are really ready for prime time, but keep all the goodness of the ImageJ 1.x API as well. And we'll be showing off some examples that do that. And then the other thing that was really challenging, and we're still polishing, is that the blue point there, that ImageJ 1 and 2, they have completely separate data structures, and on the fly they get translated back and forth. So you can open an image in ImageJ 1, which is an ImageJ 1 image, and then you can write a script that does something to an ImageJ 2 data object, and it says, oh, you needed an ImageJ 2 data object, but there's only an ImageJ 1 image, I have to translate it. And so it's very complicated under the hood, actually, what's happening to make all that possible. And people still find limitations with it, but it makes migration for users and script writers much easier. All right, I just want to mention one other thing about maintaining, right? So I said that one of the mission statements is to maintain backwards compatibility with ImageJ 1, but it actually goes way more beyond that, right? Like you want to maintain backwards compatibility in general. If someone releases a new version of a plugin, it needs to keep working. If I update ImageJ 2, the core of it, it shouldn't break your plugin that you wrote and put on an update site. And so that turns out to be really challenging. So like I said, Fiji is ImageJ 2, but with a bunch of plugins. It's basically an update site. You can think of Fiji as an update site. That is what it is. But it's a huge update site that has over 130 plugins. And in order to make that possible, we have to very carefully keep track of all the versions of everything, and does this version work with that version? And so of course we lean on computers a lot to do this, tooling and stuff. So that's just what this slide is about, that we make sure we have everything in GitHub, we do versioning, we use Semver, we use a Maven idea called the Bill of Materials. So that way, if you want to know, does this trainable Weka segmentation version X work with TrackMate version Y, all you have to do is look it up in a table, basically. Or you can say, I have version X of this. What version of TrackMate do I need? And there's a list that tells you this. I mean, you wouldn't manually go look, but this is what the computer is doing, right? So it has a big old bill of materials list. And then the last thing that's new, for those of you who are super techie and want to look at my nerdy shell script, you can click on the side Java melting pot, which Stefan coerced me into writing back in July, and it was a great idea. And it still needs to get finalized, like it's working, but it needs to get slapped up on the web so that it runs automatically and stuff. But it's really going to make, it's going to catch problems sooner, so that if things break, you as the users aren't getting bitten by big weird error messages as often. So it'll be good. All right, moving on to unification of online resources. So you probably have seen that there's a website called, the tutor started an ImageJ wiki before Fiji started their Fiji wiki. And now that ImageJ 2 has absorbed some of the core things from Fiji, it's now the ImageJ wiki. And so there's an ImageJ documentation wiki and also an ImageJ wiki and also the actual ImageJ 1.x website. And then everybody who publishes plugins likes to make their own thing too. So Fiji had a list, there's a list on the official page, there's the MBF thing, and so on and so on, and it just goes on and on. And so that's really, I mean, I already talked about update sites, you guys know about them, so I won't belabor it, but we wanted to go from this to some much shorter list. And so the picture here is actually kind of important. I promise no more analogies, and so this is breaking my promise just for a second. But you notice that, yes, there's people standing on each other's shoulders, building on each other or whatever, but there's like a bunch of short little ones, right? So what we wanted was to try and, build taller towers. This is a horrible analogy because these people are going to fall down or whatever, and that's not what happens. It's actually good to build on each other, but it's still, we wanted to have, a central list of stuff where everybody who puts something out can put it on the list of update sites, and then you just tell your colleague, check this box, and you have my stuff. So that was from a social perspective. We wanted to make sharing easier there. And then as you know, the updater is the tool that makes that possible. So from more of an architectural standpoint, and as far as unifying the websites, we want imagej.net to be like a central portal for all things ImageJ. And so in order to make that happen, if you go to imagej.net, you find the ImageJ wiki, which is and was the Fiji wiki, but I've gone through and I've generalized many, many things in there. I would recommend using that as like your first point of entry for searching for stuff. Well, search.imagej.net, actually, I'll show that to you. I did this thing and I announced it, and then like nobody knew about it still. I don't really know how that happened. There we go. So it's really ugly, and the good news is that if you're a programmer, you can click this link and submit CSS style changes to me and make it look less ugly. But in any case, all it does is it's just a really quick way of doing searches. So I don't know. By default, it searches Google, and it searches all of imagej.net, and I'll tell you in a second why that's amazing. So it found the trainable weka on the wiki, for sure. I don't know if there's anything else relevant, but in some cases, oh yeah, so like here, look, it found a bug report, or a notification about some bug on the ImageJ bugs mailing list, because this thing is also exposed through imagej.net. So Google search is really cool by domain, because anything that's foo.imagej.net is part of it. So it will search the sites, it will search mirror wiki. So this mirror, this is ImageJ 1. It's all of the goodness on the NIH website. And it's all exposed through imagej.net. And actually, you don't even need to go to mirror or wiki. I'm just showing you this so that you know that under the hood, it's backed by those two sites. If you go to imagej.net/index.html, then you get ImageJ 1. But if you go to something that's like a capital letter, then it figures out that's the wiki and it goes to the wiki. So essentially, imagej.net has everything. And the searcher is helpful for searching for bug reports or whatever. You saw a number of buttons for searching different things. And then this is personal update sites. So you can just see all of them are there as well. And they're now also searchable. And then there's also developer resources as well on imagej.net, which if you're a developer, you know what these things are for the most part. Maven repository, continuous integration, stuff like that. My favorite is this one, which I'll just show you quickly. The status. We wrote this to track which components need to be uploaded to be given to users. So anytime there's a change on the master branch, this tells you by making a red X, and it's like, oh, someone has improved ops and it hasn't been released to users yet, so it's waiting here on this list to be released. Anything that's up to date and has been released and master is matching what's available for users has a nice green check mark. So as you can see, there's a lot of components in Fiji and ImageJ. A lot. Quite a few. And if you don't want to see Fiji, you just turn that off and it's a little bit shorter. There's still quite a bit. All right. So, leading, my last thing. I know I'm short on time here. One thing that I've been focusing on in the last year or two. So you probably know, many of you know Johannes Schindelen. He's the guy who started Fiji and was tirelessly dedicated to it for 6 years. Well, as of late last year, he basically retired from the Fiji project, and he's now moved on and he's working at Microsoft. And he's still around for helping out, but he's really stepped down as the maintainer. And so to fill the void, I'm also maintaining Fiji, which I can tell you I don't want to be doing. I love Fiji and I want it to succeed, and I want you all to love Fiji, but it's too much work. It's too much for one guy to do ImageJ core stuff and Fiji. And so it's been tough, but fortunately I've had a really talented co-developer who's really matured a lot and is amazing and helps me every day, and that's Mark Heiner. So I want to especially thank him, because the two of us are the duo now who essentially make it all happen. And there's a lot of people in the community who deserve a lot of praise, but really Mark and I do a lot of the dirty digging in the ditches. So okay, so anyway, managing expectations. I'm not trying to compare you guys to toddlers, but I'm just pointing out that if you have a toddler, it's very important that you know how to manage your expectations with them. Since I've had kids, it has helped me a lot to deal with adults because they're much more reasonable. and yet, a lot of the same things are important, right? You have to be very clear with children about, this is what I expect out of you, and this is what's going to happen, and you get a cookie when you do this and not that other thing. And so it's the same thing. Like, I think one of the things about Fiji over the last few years that made it challenging is it's difficult to communicate all this and to tell people, well, under these circumstances, bugs will get fixed. People aren't being paid to do this and those kinds of things. To tell them respectfully and to make it, to kind of align everyone's expectations, because a lot of us on computers, we're used to, everything working really, really well because some company developed it and they have a big user base who pays for it. And open source is really a different thing. And so, yes, you want it to be really polished, but I showed you my big slide of all those people. Those people are not all working on this every day. If they were, then things would be a lot nicer. All right, so you can click on all these links. I was going to walk through some of them, but I won't because we're low on time. But these are all questions that people ask and have, and they're all on the wiki now. I worked really hard to document exactly what it takes to get your plugin into Fiji. So if you have a plugin and you want it to be shipped with Fiji, then how do you do that? Well, now there's a big guide that shows you everything technically that you need to do for that. So the wiki has matured, and I think that's been fleshed out, and I would suggest you look at it if you're interested in that stuff. And the last thing is there's a FAQ as well. That's what the question marks are. All right, so briefly to talk about the future of ImageJ. Well, I can tell you briefly some of the things that I plan to do in the next year. Well, in general, we really want to polish the user experience. So those of you who use Macs, I'm looking around here, I guess there aren't that many of you. A lot of programmers use Macs. If you've used Macs, you've probably bumped into how annoying it is to use ImageJ on a Mac right now, and especially like 6 months ago. It's still annoying, but slightly less. But it's because Apple has just kind of messed around with how Java works on Macs. And so we really need to catch up and make things work better there. So I want to have a dedicated ImageJ2 download. So right now, if you want to download ImageJ2, you can't. You can go to the downloads page and you can download Fiji. But that's a different thing, right? Like, that comes with all this stuff. If you want to download just ImageJ2, you have to download Fiji and then go into the update sites and uncheck Fiji and delete all the plugins, which is really not good. So ImageJ2 should be a download. And then we just want to work to make things more robust, to get components out of beta. We've been doing that over the last 5 years. SciJava, this low-level thing, it's out of beta. It's been out of beta for years. ImageLib last year came out of beta, and soon we're going to finalize the data model of ImageJ2 and bring that out of beta. So it's getting better. It just takes time. And then the last two things I want to do are, I want to improve this ops library to be able to do like everything you could think of with image processing, and just try and add tons of algorithms to it. And I can't do that all on my own, but we're having hackathons with others. And then lastly, I want to do some training. So this hackathon that's coming up, we're going to do a hackathon following the conference actually with some people. And there are two main goals. One of them is to work on ops, but the other one is to train people. So I want to train people to know more about ImageJ2, like from a technical side, so that we get more people who can contribute and really not just write plugins to do science, which is great, but you all can write all the plugins in the world to do science, and it won't make the core better. The core needs to be better because everyone benefits. So like ImageJ2, my talk is unfinished. I have one slide just to show that it's never done or keeps going forever. I learned lots about biting off and chewing in the last couple of days as I made this talk. But I just want to close by inviting everyone to please join the effort. If you have any expertise, resources, Even if you are not a programmer, but you run a group and you can have a student, anyone, I would just implore to get involved in not just solving your own scientific problem, but trying to benefit the community and the world, and join SciJava, because we can all do handstands. So thank you very much. Questions? Yes, I explained it perfectly. So certainly as a user, the most valuable thing you can do is use it and tell us if something is wrong and broken. So bug reports are great. That said, I will apologize in advance that with such a small team, when you report a bug and it might not be fixed right away, it might not be fixed for a long time. We have hundreds or thousands of bugs in the bug tracker. Thousands of bugs. So many bugs. But we just keep trying to address the things that are the most pressing, and so the squeaky wheel gets the grease. We used to say that Fiji was a complaint-driven project, and I've tried not to say that as much anymore, because in a way, that's not the way you want to operate, right? One of the talks or workshops, I think it was Tiago's workshop, had this great quote from Henry Ford that said, if I asked the users what they wanted, they would have said faster horses, from Henry Ford. Yeah, and I think that's, people in software like to quote that. It has its limitations of applicability, but there's some truth there too, right? So like, we are thinking about the general case and stuff. But yeah, no, filing bug reports is great. But like I said, the most helpful thing you could possibly do would be to write a grant and get some money and hire some programmers and join. That would be amazing.
So you explained that in the future we're going to deal with more dimensions, bigger images, accessing from internet, from online streams, whatever.
Right.
But it's also something that it seems like it's coming, is a multi-resolution.
Yeah.
Yes, I don't know if in any of these projects where in the meta, is there any structure that will deal with these pyramidal images, compressions, that you can actually do algorithms in that kind of representation?
Yeah, for sure. So both the OME group and the SciJava/ImageJ2 Scipio projects are thinking about that and making active development towards that. So Bioformats already has a multi-resolution support, and Omero does to an extent. Scipio is currently being updated to do more block-based image reading instead of like per plane, but to consider like more flexibly what is a block of data, and then the blocks of data it's on our radar for sure. So I think that you're right. There are some complexities there that I don't know that we're going to explicitly solve, like, well, which resolution do you analyze and things like that. I mean, obviously, you probably want to analyze the full resolution, right, most of the time, unless it's too expensive computationally. But certainly, the underpinnings will be there soon, within the next couple of years, I would say. And then, like I said earlier in my talk, you kind of have to iron out the kinks as you go, right? So, like, we'll put the underpinnings there, and then we'll see what we can build. And if what we build isn't good enough, then we'll tweak the underpinnings to be good enough. Does that make sense? But yeah, it's certainly something that we're very cognizant of. It's the thing I'm more scared of actually is cloud computing, because ImageJ2 is still very focused on running Java code on your computer. It's, we figured, well, if people want server stuff, there's already tools like Omero, and there's a lot of cloud computing stuff that's being developed. But ImageJ, you could certainly use it on a cluster. You could certainly do that, but like GPU computing, there are some talks this conference about it, but you have to kind of bend over backwards right now. ImageJ3, that's where we're going to have everything's on the cloud. You just click a button, and some server in California just tells you. Yes. Sometimes it is.
Yeah, well, for critical things. You put a bug report using the Fiji bug report, which I highly recommend. You'll get an answer within a couple of hours, basically. I mean, But, you know, I put something on in the morning, by the end of the day, I've got to work around it.
That is the nice Europe-US advantage. Yeah, the disadvantage for us is every time I think of something great, I'm like, I got to talk to Stefan about this. And then I'm like, oh man, it's noon and it's 4 p.m. He's probably going to bed or whatever. Well, he might not. Well, he's not in the EU anymore, but yeah, lots of people that we collaborate with are there. So works both ways. Thank you very much, everyone.